All right, welcome to part 3 of our lesson on similar triangles and the angle-angle theorem. So this next diagram here has a long list of questions that we're going to answer about it. Okay. I think we can assume that all these triangles are similar. It doesn't quite say it, but I think that's a safe assumption here. Okay. All right, so let's begin with question number 5. We want to find the measure of angle AGB. Okay, so AGB is that angle right there. Okay. Well, I see that I have this triangle here, and 2 of the angles I know, 1 of the angles I don't know. Okay, so let's just call that angle X. Okay, and so we can go ahead and write X plus 63 plus 90 equals 180. Okay, X plus 153 equals 180. Okay, if we subtract 153 from both sides, we get X equals 27. Okay. All right, so now we can go in here and we'll go ahead and write 27 degrees. All right, the next angle we want to find is the measure of angle EGD, which is that angle right there. Okay. Well, I can see that that angle is directly across from the angle I just found, right? If I look at these 2 lines, okay, then I get a pair of vertical angles. Okay, and as we know, vertical angles are congruent. Okay, so we can go ahead and mark this angle as 27 degrees as well. Yep. All right, next we want to find the measure of angle BCG. So BCG is that angle right there. Okay. Now because this triangle I'm assuming is similar to this triangle, right, then I'm going to record that as 63 degrees. All right, let's find the length of AG. Okay. So AG, let's change colors here. So AG is this side right here, okay, which is the hypotenuse of a right triangle. We see that the bottom side is 6. The other side we don't know, but we see that in the triangle below it, it's 3. So I think it's safe to say that this is 3 as well. So we're going to use the Pythagorean theorem to find the hypotenuse here. Let's call it h. Okay. Actually, no, let's call it c, right? A squared plus b squared equals c squared. Okay, so 3 squared plus 6 squared equals c squared. That's 9 plus 36 equals c squared. That's 45 equals c squared. Okay, we'll take the square root on both sides. Okay, so c is equal to the square root of 45. Okay, so we'll write that in square root 45. Okay. And so that means that this is going to be the square root of 45 as well. We can say that's a right angle there. Let's see, we can say that's a right angle right there. Okay, so let's record this square root of 45. Okay, AB, we said that was 3. FE, okay. Well, FE is this distance right here, which we know is going to be congruent to that distance right there, and altogether it's 3. So if I just divide 3 into 2, I get 1.5 for each of those segments there. So 1.5, 1.5. Okay. All right, what is the length of GF? Okay. Let's see if we can erase some of this work now. Okay, so GF is a hypotenuse of one of the small triangles. Okay, let's switch here. So here's GF. Okay. All right, so let's call that C now, because again we like to use A, B, and C when we're using the Pythagorean theorem. Okay, so A squared plus B squared equals C squared. We can write 1.5 squared plus 3 squared, right? 1.5 and 3 are the length of the legs, equals C squared. Okay, 1.5 squared. It's 2.25. 3 squared is 9. That equals C squared, so that's 11.25 equals C squared. And then of course we're going to square root both sides, so C is equal to the square root of 11.25. Okay. Not the prettiest of numbers, but that's okay. Alright, square root 11.25, and let's go ahead and write square root 11.25 there. Okay, square root 11.25. Okay. Alright, and then finally for question 13, we want to find a triangle that is similar, right? This symbol means similar to ACG. Okay, so ACG is this triangle right here. And let's see if we can find one. Well, there's actually 4 triangles altogether that are similar here. We, I guess, only need to name one of them, though. Okay. All right, so let me erase all these marks now. Okay, so triangle AGC. You know what? I was looking at the wrong triangle. AGC. Okay. Well, that looks like an isosceles triangle, and this looks like an isosceles triangle. Okay. So let's go ahead and color code all the angles. Okay, so A is 63, and F, I believe, was 63. These are vertical angles, so we know that they're going to be congruent, and then those are another pair of congruent angles. Okay, so let's see. The name of the smaller triangle, A is yellow, so F is yellow. G is red, and G is red. C is green, and D is green. So it would be FGD. Okay. And then that brings us to question number 14. Using the diagram, write similarity statements for each triangle similar to EFG. Okay, so let's look at triangle EFG. Okay. So EFG is that triangle right there. Okay. And so what I'd like to do is I'd like to take the other 3 triangles and kind of rotate or reflect them so that they have the same orientation as EFG. Okay. So if I take the other small triangle and I reflect it, then we would have E, D, G. If I take this triangle on the top right and I reflect it horizontally, then we'd have B there, A there, and G there. If I take this triangle on the bottom left and I rotate it 180 degrees, then this would be B, this would be C, and this would be G. Okay. All right. So now let's go ahead and color code all of the the angles. So E is the right angle, so I highlighted all the right angles yellow. F is right there, so the corresponding angles are AC and D, and then G is the most acute angle, and so we'll highlight that there. Okay. Right, so triangle EFG is going to be similar to triangle EDG. It's going to be similar to triangle BCG, and it's going to be similar to triangle BAG.